Hi everyone. Through this class, we are going to study about the construction and working of octal to binary and decimal to BCD encoders. Encoder is a device or process that converts data from one format to another. In digital logic, an encoder is a combinational circuit that converts binary information in the form of 2 raised to n input lines to n output lines, which represent n-bit code for the input. For simple encoder, it is assumed that only one input line is active at a time. Example is octal to binary encoder. The logic symbol of octal to binary or 8 to 3 encoder is like this. Here there are 8 inputs D0, D1, D2, D3, D4, D5, D6 and D7. And there are 3 outputs A, B and C. These inputs D0 to D7 corresponds to decimal digits 0 to 7. And the outputs A, B and C corresponds to 3-bit binary code. Truth table of octal to decimal encoder is shown here. Here we can see that the inputs are D0, D1, D2, D3, D4 up to this D7. And the binary outputs are A, B and C. And the decimal equivalent of input is shown here. When all the inputs are zeros, then decimal equivalent is 0 and the corresponding output it is 0, 0, 0. And when D1 is 1, then the decimal digit is 1 and the output is 0, 0, 1. When D2 is 1, decimal digit it is 2 and the output it is 0, 1, 0. And when D3 is 1 and all the other inputs are zeros, then the decimal digit equivalent it is 3 and the output is 0, 1, 1. And the D4 input is 1 and all the other inputs are zeros, then the decimal digit it is 4 and the output binary equivalent it is 1, 0, 0. And when D5 is 1, then the decimal digit it is 5 and the output is 1, 0, 1. And when D6 is 1, then the decimal digit it is 6 and the binary output is 1, 1, 0. And when D7 is 1 and all the other inputs are zeros, decimal digit it is 0 and the 3-bit binary output is 1, 1, 1. And here we can see that only one input line is active at a time. When D1 is active, all the other inputs are 0. And D2 it is 1, all the other inputs are zeros. So up to this, when D7 it is 1, all the other inputs are zeros. And here we can see that the C, that is the most significant bit output, that is 1 only when this D4 high or D5 high or D6 high or this D7 high. So the Boolean expression for the C, we can write it as D4 or D5 or D6 or D7. And this B output, it is high when our D2 is high or D3 is high or D6 and D7 are high. Then the Boolean expression for B, we can write it as D2 or D3 or D6 or D7. Then this A output, that is high when D1 is high or D3 is high or our D5 high or D7 high. So A, the Boolean expression is D1 or D3 or D5 or D7. We can realize octal to binary encoder using 3 OR gates like this. Here the inputs given for these OR gates are D1, D2, D3, D4, D5, D6 and D7. And we know that the Boolean expression for getting A is D1 or D3 or D5 or D7. So for the first OR gate, here the inputs given are D1, then D3, D5 and D7. Then we get the output as A, that is the least significant bit output. Then for getting B, the Boolean expression is D2 or D3 or D6 or D7. So the inputs given are D2, then D3, then the D6 and last input is D7. And for getting most significant bit C, the Boolean expression is D4, D5, D6 or D7. So the inputs given for third OR gates are our D4, then D5, then D6 and D7. The logic symbol of decimal to BCD encoder or 10 to 4 encoder is like this. Here there are 10 inputs D0, D1, D2 up to this D9 and there are 4 outputs A, B, C, D like this. The truth table of decimal to BCD encoder is like this. Here the inputs are D0, D1, D2 up to this D9 and the BCD outputs are A, B, C, D like this. And when all the inputs are zeros, then the output BCD output will be 0, 0, 0, 0. And when D1 is 1, the decimal equivalent is 1 and the output will be 0, 0, 0, 1. When D2 is 1, decimal equivalent 2 and the output is 0, 0, 1, 0. When D3 1, decimal equivalent is 3 and the output is 0, 0, 1, 1. And D4 1 output is 0, 1, 0, 0. D5 1 output is 0, 1, 0, 1. D6 1 output is 0, 1, 1, 0. D7 1 output is 0, 1, 1, 1. D8 1 output is 1, 0, 0, 0. When D9 is 1, output is 1, 0, 0, 1. And here we can see that one input line is active at a time. And the D output is high only when D8 high or D9 is high. So the Boolean expression for D we can write it as D8 or D9. And this C output is high when our D4 high or D5 high or D6 high or D7 high. So C Boolean expression is D4 or D5 or D6 or D7. And for this B output, it is high when D2 high or D3 high or the D6 value high or D7 value high. So the Boolean expression for B output is D2 or D3 or D6 or D7. And A is high when D1 is high or this D3 is high or D5 is high or D7 is high or D9 is high. Therefore, the Boolean expression for A output is D1 or D3 or D5 or D7 or D9. We can realize decimal to BCD encoder using 4 OR gates like this. Here the inputs are D1, D2, D3 up to this D9 and the outputs are A, B, C and D. And we know that the Boolean expression for our output D, that is most significant bit, it is equal to D8 or D9. So here there are two inputs connected to this last OR gate and we get the output as D. And for C, the Boolean expression is D4 or D5 or D6 or D7. So we need 4 inputs D7, D6, D5 and D4 as the inputs for this third OR gate and we get the output as C. And the Boolean expression for B output is D2 or D3 or D6 or D7. So here also we need 4 inputs. The inputs are D2, D3, D6 and D7. So the output will be B. And for getting this A, the Boolean expression is D1 or D3 or D5 or D7 or D9. So here we need 5 inputs. So the inputs are D1, D3, D5, D7 and D9 for this first OR gate. So here we get the output as A, that is the least significant bit.